Hi, we have set up 3 shaft measuring machines where we would like to demonstrate you how the quality standards of our BiG shafts are. I'm at the first shaft station. BiG has picked now 2 shafts from one of the biggest and shaft manufacturers in the world. Both shafts say the same flex, same style and design and weight, and let's see how these shafts are going to perform now. On this first machine we are going to measure the consistency of this shaft just by clamping the shaft here underneath, pressing it down with a 1-inch pressure, twisting it around right here, and you can see also how this shaft will flip just by, that's how we can tell it. Look how hard I have to turn, it just jumps in. And on this device here I measure the weakest, the softest part, and it's just about 4.4 kilo that the shaft is at this point being stressed. My goal now is to find the stiffest point at this flex. I'm going to do this by pressing the 0, twisting the shaft, and see where the stress is so high that I get a higher number. This is now the stiffest part on the shaft, difference of 518 grams. We're going to compare now our BiG shafts with the other BiG manufacturers just by clamping our shaft in our shaft machine, twisting the shaft and finding the weakest spot. Weakest spot here is 5.7 kilos. Now pressing the 0, twisting the shaft again to find out the hardest, stiffest point. Right here, 1.3 kilo, 125 grams. So the difference from our shaft to the shaft before is our difference 120 grams and the other shaft 500 something. I'm now on shaft station 2 and I'm going to show you how this shaft from the major shaft manufacturer is going to accelerate once it's built into the club. Look at this laser beam. Now you can see, or you can imagine, how this club head is going to deliver on a certain or different spot to the ball just by bouncing back and forth. This shaft should perform, once it's built in properly in the club, on a horizontal plane just like this. I'm now on the third shaft station, where we're going to measure on both shafts the tip section from here to here with a 454 gram weight. I'm going to press down here and see what happens. 417, try again. 417. So this shaft with 445 grams has 717 cycles per minute. Let's switch and see what the other shaft does. Now I've put the other shaft in this frequency machine to see how the tip section performs from here to here. Let's see. Now this measures 660 cycles per minute. 650, a huge difference to the cycles before. Now I have measured on the third machine both shafts at the tip section, and they show a big, huge, dramatic difference. One shaft had 652 cycles per minute, the other 718 cycles per minute, which is a difference by 1.5 flexes. So 1.5 flexes difference, but both shafts are supposed to be the same. Now BiG does the same. We all measure the shaft, but the difference is that we sort them out so we know exactly what we do once we build our clubs. Now when we build a BiG driver, we know exactly what we do. We measure the shaft on different spots. we have seen on shaft station number 1 that we measure the thickness and the walls of the shaft, finding out the weakest and the softest spot. If the difference between these 2 points is too high, we take the shaft away and don't use it. If it's good within 100 and 200 grams, which is excellent and nobody has, we use it. That's a big shaft. On the second shaft station, we measure the correct CPM, and we also make sure that we build the shaft on a horizontal plane. So the shaft sticks in the head, and once you put some pressure on the shaft is going to accelerate on one single horizontal plane. On the third station, we measure the tip stiffness and also write it down. We measure the tip stiffness because right here in this part we say that the shaft is going to be stressed the most during the swing. So once we measure, we know exactly whether this shaft has a firm tip stiffness or a soft tip stiffness, and we also know the performance data from the customer and can take the correct shaft and build the proper and perfect driver for our customers.